Good afternoon, and welcome to this afternoon's Ultra Lubricants Protecting What Counts webinar series. My name is Denise Caesar, and I will be your host this afternoon. It gives me tremendous pleasure to welcome all of you who are viewing us here on the Zoom, as well as those who are tuning in live on our YouTube channel. It's a pleasure to welcome you to our third in our series of webinars for the Ultra Lubricants brand. Ultra Lubricants has partnered with the National Energy Skills Center and their School of Continuing Education for the hosting of these webinars. And 3 webinars in, we're very pleased with not only the way in which it has been unfolding, but the comments that we've been receiving online are very encouraging because it says to us that you, who we are targeting, you are certainly appreciative of what we're doing. So we're happy to have all of the mechanics, spare part outlets, the NESCs, automotive students who are joining us. We're happy to have all of you here. This evening's webinar is entitled Shifting Gears as we focus on manual transmissions. But let me just tell you about the 2 partners who are collaborating on this. The NESC School of Continuing Education is responsible for initiating, creating, developing, and implementing a lot of growth opportunities amongst multiple organizations. And their intent is to reach as many new markets as possible and to form new partnerships with other agencies and organizations. As a matter of fact, they were very enthusiastic when NP approached them with the desire to host these webinars series. The Ultra Lubricant brand, as you probably know by now, if you've been tuning in for the last 3 sessions, the Ultra Lubricants brand is the premier lubricants brand of NP. And we offer a range of internationally accredited motor oils for all classes of diesel and gasoline engines, as well as a host of automotive products. And of course, we take pride in blending the world-class lubricants that are uniquely designed for our local tropical conditions. This year is Ultra's 40th anniversary. So we've been doing this for a while. And over the years, as a result of doing it for a while, we've come to be known and developed a strong reputation for blending OEM-approved and API-certified lubricants, including our own brand. This has resulted in opportunities for us to blend for multinational brands, which you may not have realized before. And this has allowed Ultra to be on par with many of those quality brands of those international brands that you're familiar with. So Ultra is an experienced blender of OEM-approved lubricants. We manufacture API-certified lubricants. And of course, if you need to, or you need us to, we're happily willing to blend on your behalf. That's for all the multinationals who are tuning in and looking for a capable partner to work with. But let's give you now a behind-the-scenes look at how we make our lubricants. We stand behind it and we have confidence that it is of high quality. But do you know how we make it? Take a look at this video as we share with you how we make the Ultra Lubricants brand.
In the Caribbean, we move to the rhythm of the islands, its people, flavors, and cultures. At National Petroleum, we focus on this movement as the energy that guides us and as a leader in the research, development, and manufacturing of the only brand blended specifically for our tropical conditions. We take pride in facilitating this movement day to day, town to town, and nation to nation. As a team, from our talented engineers to our dedicated transport partners, NP has embodied these values into our Ultra Lubricants line. Designed for a demanding climate, frequent stopping, and overall engine efficiency, the Ultra brand represents the next generation in lubricant technology, including 100% fully synthetic oils, with innovation and products that perform under the rigors of the exacting specifications of a range of today's modern vehicles, making the NP Ultra Lubricants line a brand that has been trusted throughout the region for decades. In that time, you may have come to know the brand, but do you know how we make it? The process begins with the delivery of high-quality base oils and additive packages shipped by tanker to the plant. Purchased from leading international suppliers with proven track records for superior quality, these raw materials are pumped into holding tanks for use in each new batch to be blended. The work of identifying the exact blend needed to obtain the required specifications is performed by certified technicians at the on-site lab. Exacting specifications are met for each new batch produced, and orders are then sent to the blending station. Here, the work of skillfully bringing all components of a well-blended world-class lubricant begins. With a blending capacity of over 20 million liters per annum and an impressive 249 stock-keeping units produced, the blending operations of the plant manufactures over 50 different lubricants across a number of classifications. Over the years, NP's excellent reputation for blending OEM-approved and API-certified quality lubricants, including its own Ultra Lubricants, has resulted in opportunities to blend for other multinational brands, thus putting Ultra Lubricants on par with and even exceeding the quality of other international lubricant brands. The filling lines are where various sizes of bottles, pails, and even drums are filled in a fully automated process. With an average of up to 1,200 4 and 5 liter bottles and up to 600 pails filled each hour, this cutting-edge filling plant offers world-class performance, efficiency, and accuracy. Additionally, specially ordered 55 American gallon drums of lubricants are filled on a dedicated line and produced on site. The freshly blended lubricants are pumped overhead to the designated line to match the orders being filled. On this line, the pails first get their labels, then along to the filling station, where they are filled using state-of-the-art mass flow meters at a rate of up to 600 pails per hour. With the lubricant sector growing exponentially, this top-of-the-line filling station makes it possible for NP's Ultra Lubricant lines to meet the demands of the local and regional markets. At the other lines, bottles are swiftly led from labeling to filling, then capping, all within a fully automated process. This carousel individually seals up to 1,200 bottles per hour. Each bottle and pail are imprinted with a quality control traceable number and displays the date and time the product in each bottle was filled, giving an accurate record that meets international quality assurance requirements. A final inspection, and then it's off to the individual packing machines. This highly efficient and very impressive process completes the packing stage within a caged area designated for the safe and efficient operation of a high-tech robotic arm. With its anti-collision functions enabling very rapid movements, this robot is able to lift up to 150 kilograms of stock at a time. With great precision, the robot keeps the packing process up to speed, just as the NP brand keeps a pace of new and emerging markets, customer needs, and technological advancements across the nation and across the region. Ultra Lubricants, world-class lubricants for tropical conditions.
And there you have it. We just gave you a glimpse behind the scenes into how we make our quality lubricants right here at the NP Sealots Port of Spain compound. But now that you know how we make it, let me tell you where you can get it. Our Ultra Lubricants brand is available at multiple spare part outlets across Trinidad and Tobago. 700 plus spare part outlets sell our quality lubricants. But in addition to that, if ever you need to get your hands on any lubricants, please visit any of our quick shops, the 38 plus quick shops, whether it's a Quick Shop Plus, Quick Shop Mini. Our lubricants are also available at our quick shops. And for those of you who are tuning in on the Zoom, if you look into the chat, you will see that we've posted the names and contact numbers of our Ultra Lubricant sales reps. They, of course, are always available to assist in terms of orders, or if you're looking for particular products, we're here to serve. And those are the names that you can reach out to. It's Stephen Subaya and Sulin Harilal. So moving on to the next item on our agenda, we always take the opportunity, after showing you how we make our quality products, we always like to dispel any misconceptions or fake news that might be circulating out there. So this is the opportunity for us to do that. Over the years, we've heard 4 pieces of fake news that we take the opportunity to dispel and set the record straight. So let's deal with the first one. You may or may not have heard people say that ultra lubricants are blended with used oils or substandard base oils. That is absolutely fake news and couldn't be further from the truth. The real news or the facts are that our brand of lubricants are OEM, which is Original Equipment Manufacturer, and API, American Petroleum Institute, approved lubricants. And they're blended with base oils and additive packages from leading international suppliers who have a proven track record for superior quality. Then there's the other matter of persons saying to us on occasion that when they go to the dealership to service their vehicle, if they ask for Ultra or if they take their gallon of Ultra so that the dealership can use it, the dealership would tell them that using Ultra lubricants will void their warranty. We're saying categorically that that is incorrect information. That is fake news. It's not true. You see, any brand of engine oil that meets the specifications that are stated in the owner's manual of your vehicle, then that brand of lubricant is safe and effective and can be utilized without voiding the warranty. So the next time you go to the dealership, by all means, pick up your Ultra lubricants at your neighborhood quick shop, pick it up at the spare part outlets, and go with confidence, knowing that they cannot void your warranty and that your car is covered both on and off the road. Here's another item that we sometimes encounter in terms of fake news. We've heard it said before that Ultra lubricants are inferior to some of the popular international brand of lubricants. We're setting the record straight again. Ultra lubricants is a locally blended, high quality brand of lubricants, and the brand uses high quality base oils and additive packages that are purchased from reputable suppliers. And these suppliers from whom we purchase these additives sell to other OEM approved multinational brands just as they do to us. So that our brand of lubricants, the Ultra Lubricants brand, is certainly approved. And not only is it approved by OEM and API, but it can hold its own and stand on even footing with any of the other international brands. Trust us when we say that. Then the last item is sometimes you hear people say, probably unknowingly, that Ultra does not have a synthetic line of engine oils. To all of you viewing us on Zoom and looking at us on the chat or looking at us on YouTube, rest assured, Ultra produces high performance, fully synthetic engine oils that are designed not only for diesel engines but also for gasoline engines. And the brand is specifically blended to meet the demands and the rigors and the uniqueness of our local tropical conditions. So there you had it. Fake news, dispelled, corrected, put to rest, and we've shared with you the accurate information or the truth as it relates to the Ultra Lubricants brand. We're happy that you're staying tuned with us, and we certainly hope that the last few webinars have been not only instructive but also beneficial, particularly to our mechanics who join us every month. We're happy to have you. And this is why the focus of this webinar series, this particular webinar, I should say, is on the manual transmissions. As mentioned, the theme is called Shifting Gears. To take us through a presentation that speaks to how the Ultra Lubricant brand is well equipped to provide quality products for manual transmissions, we now invite Mr. Dwayne Bryan, our technical associate, to take us through that presentation. Dwayne, would you address us, please?
Good afternoon, all, and thank you for joining us for our third session of Ultra Lubricants. Let me share the screen now. All right, so this afternoon, we're going to take a look at the Ultra Lubricants manual transmissions. So manual transmissions, as we all know, deals with gears. So we're going to look at the Ultra gear oils that we have available for manual transmissions. Before we do that, we like to always give you a nice overview of the blending operations at our sealers facility. So as you saw the video, let me just give you a little overview again of our operations. National Petroleum has a first-class manufacturing operations at sealers with robust distribution channels throughout Trinidad and Tobago and the Caribbean. We have approximately 11 distributors throughout Trinidad and Tobago and 15 distributors throughout the Caribbean region. We have contract blends for world-class brands that we also blend in Trinidad and Tobago. We also have a blending capacity of over 20 million liters per annum. So therefore, we can blend for the entire of Trinidad and Tobago and the Caribbean region at our sealers plant. We blend over 50 different lubricants manufactured under the different categories of engine oils, greases, transmission fluids, gear oils, which we'll be looking at today, coolants, industrial oils, as well as synthetic compressor fluids. At National Petroleum, we also have an ISO 9001-2015 certified laboratory facility. This facility is also linked to the Institute of Petroleum in London, and all of our equipment are calibrated by the Trinidad and Tobago Bureau of Standards. At present, our laboratory facility is also getting certified to the ISO 17025 standard, which will give us global recognition in terms of testing of lubricants and fuels. We also have technical support services that are trained by the Society of Tribology and Lubrication Engineers and are certified as well. We provide after-sales service, such as oil analysis, where we test the lubricants to ensure that they are fit for use and ensure that the equipment are operating under good conditions. We provide lubricant consultancy, seminars such as this, as well as waste oil disposal for any of the lubricants that are used at National Petroleum. So just to give you an idea, how does an axle work? So where do our manual transmission or our gear oils work? It works in axle and differentials. So the differentials are made up of several different gears. So we have the drive shaft, which is connected to the pinion gear, right? That drives the ring gear and is bolted to the differential carrier, right? These use about two sets of small gears as well, right? These allow the wheels that we know to turn at different speeds when cornering, right? So the function of the rear axle is to transmit driving torque to the wheels to give you that speed reduction when you're mashed and also to change direction in motion, right? The lubricants, the gear fluids do not only apply to one type of lubrication. So we have to cover, the gear fluids have to cover all the three classes of lubrication, maybe boundary lubrication, mixed film lubrication, or hydrodynamic lubrication. So the gear oils must have all these different types in order to cover that type of lubrication. Some other applications and critical factors for the gear oils, it must act in open differentials to transfer power, apply the same torque to each wheel, and also gear reduction. All gear oils are also what we call limited slip. It has limited slip differential capability, so therefore it can supply varied torque to each wheel depending on the traction.
Excuse me, Dwayne, one moment, please.
We're not able to see your slides.
You're not seeing the slides, Gade? Sorry?
No. Could you just check that for us, please, so that we could continue on with shifting gears, smooth operations? Double check that, please.
Sure. Yes, are you all seeing the slides now?
Yes, we are.
Good. I do apologize for that. All right, so now we talk about the axle applications and the critical factors. So gear oils, there are limited applications in terms of they are utilized for rear-wheel drive vehicles, four-wheel drive vehicles, but they are mainly utilized for original equipment manufacturers, SUVs, and trucks, right? Many of the gear oils have what we call fill for life service, but some of them are also utilized in service fills. The original equipment manufacturer is the key decision maker in choosing a lubricant. So it's very important that you follow what your OEM recommends in terms of gear oil for your axle and for your differentials. Right? In addition, there's a strong service fill market due to regular drain intervals. Gear oils are changed regularly, and fleet operators need to make a decision on which or what service oil that is necessary for use. It's very important if you're in a warranty period to follow the OEM recommendation in order to get reliable performance to keep the oils and the equipment operating in tandem. Right? So how does manual transmission fluid trends impact the fluid? So before, most gear oils or manual transmission utilize an API GL4 lubricant. With the onset of technology, the lubricants these days are API GL5, API MT1, and a new specification, SAE 7360. The lubricants are 80W90, 85W140, but the trend is moving towards 75W90 and 75W85. So we see a lower viscosity in gear oils in order to give you that fuel efficiency. The gear oils have high thermal oxidative stability, high pitting performance, and gives you performance over a different range of different gears. So the Ultra Gear Oil HD and LSD main applications. So available, we have the Ultra Gear Oil HD and LSD 80W90 and 85W140 at present, right? So they are utilized in enclosed steel gears operating under high load and speed and extreme pressure conditions. So when you see a gear oil that has what we call EP written on it, it means that it's for extreme pressure applications. They are utilized in automotive, medium and low speed spur and helical gear units, and they are developed for car and commercial vehicles fitted with limited slip differentials. Most of the gear applications are spiral bevel or hyper axle for highway and off-highway vehicles. Off-highway vehicles such as your tractors and your backhoes utilize the Ultra gear oils. Here you can see the different viscosity grades. So the SAE, Society of Automotive Engineers viscosity grades, 80W90 and 85W140. The performance specs, API GL5, also meets some military specs, as well as some different OEM specs such as ZF and MAN. The gear oils also contains what we call a friction modifier in order to give you that limited slip differential axle performance. And as you can see from the bottle, it also contains what we call clean gear technology. Most gear oils, when you utilize it, you'll notice that they leave a yellow stain on the different gears. With the Ultra gear oils, you get what we call clean gear technology that does not leave that yellow stain and gives you a longer life and a better performance in your different axle or differentials. So we recommend the Ultra gear oils 80W90 and 85W140 in utilizing for your vehicles. All right, thank you very much. If there are any questions, we'll take them via the chat or at the end of the presentations. Thank you.
Thank you very much, Dwayne Bryan, for an engaging presentation on the shifting gears, manual transmissions, and particularly from the aspect of how the Ultra Lubricants brand has a product specific for that particular operation in a vehicle. But now we've come to the meat of the matter. This is where we get into more of the technical information, more of the value-added information that most of you tune into every month in order to get. And for this, I have the privilege of inviting an NESC instructor extraordinaire to deliver the presentation on manual transmissions. But let me introduce him properly. His name is Kiran Singh Raghunanan Singh, and he's been an instructor with NESC for the last 20 years, with an automotive experience that is vast, spanning 37 years. This instructor is not only qualified by the Canadian Red Seal certification automotive and heavy equipment, auto and diesel, but he has a wealth of other qualifications and experience to back up his stature. A well-respected instructor at NESC, we are privileged to have him. If you were with us last month, you would have been impressed and in awe of his delivery as we had looked at CVT transmissions. But today he's going to take us through the presentation on manual transmissions. We now invite Mr. Kiran Singh, Raghunanan Singh to address us. Kiran?
Hi, good afternoon to everyone. Thank you for joining us this afternoon. So as we get into this presentation, we want to look at some critical aspects of manual transmission operations. So it is important that we understand some basic things about transmission operation before we seek to look into the intricate operation of the internal components of the transmission. So we use this term manual transmission, and previously these transmissions would have commonly been referred to as gearboxes. And of course, the reason for that is that they contain a number of gears, or they function in a manner where you could literally shift gears to achieve a particular function. So we want to look at the topics that we're going to look at or cover this evening so that we'll have a good understanding of what we can learn out of this session. So the first one is to state the function or functions of the clutch, because the clutch forms an integral part of the operation of the manual transmission. State the function or functions of the transmission itself. Why do we have a transmission? Why do we need a transmission? Or do we need a transmission? Describe the location of transmissions on vehicles. So we know that vehicles are configured in different ways. So all transmissions may not be located in the same position on a vehicle. One, depending on how the vehicle is built. Secondly, what the vehicle is going to be used for. Explain how gears are shifted in a transmission. And this is an important aspect of transmission operation. So while you may drive a vehicle, car, truck, whatever it might be, and you have a gear shift and a clutch pedal in the vehicle, you might be able to drive this vehicle expertly, but without understanding what is actually happening while you are shifting gears. Describe the operation of manual transmissions. So we want to know how they operate. Identify the lubrication and service requirements for manual transmissions. And here we add transmissions and transaxles, because traditionally the term transmission would have been the term that was commonly used, but now we also have different configurations of transmissions where they include other components. So now, depending on the type of vehicles these transmissions are fitted on, the transmission assembly, together with the other components that they are made up of, they are referred to as transaxles. So we start with the first topic. State the function or the functions of the clutch. And we know the clutch is operated from inside the vehicle when the driver or the operator of the vehicle mash the clutch pedal or step on the clutch pedal, and it operates something related to vehicle operation. So this something, of course, is the clutch, and we want to know what this clutch does. Well, the clutch is a mechanism that progressively connects the transmission to the engine. So imagine you have a vehicle, the engine is running, the engine is working, you have started the vehicle. The vehicle maybe stands still. You want the vehicle now to start to move. The first thing you will do is put your foot on the clutch, press the clutch all the way to the floor, and engage a gear. And then you will release the clutch pedal in a progressive manner, and the engine is now able to drive the vehicle through the clutch that is engaged. So one of the most important things that the clutch must do is to progressively engage or connect the transmission to the engine to allow the vehicle to drive. The second important thing that the clutch must do is to provide a temporary neutral position within the powertrain. And when we talk about the powertrain, we're talking about between the engine and the drive wheels. So let's say you are driving on the road and you are approaching a traffic light that turns red. It means you must stop. If you have a car with a manual transmission, one of the things that you could do as you come to a stop is simply step on the clutch pedal and press the clutch pedal all the way to the floor. And that will disconnect the engine from the rest of the drive system or the powertrain. And in that way, the clutch also allows a temporary neutral position. Now, if the car is going to stay working, but you don't want the car to drive, and this is going to be for an extended period of time, you wouldn't want to sit in the car and just mash the clutch for a long period of time. So it means you will shift the gear to neutral. So stepping on the clutch to provide this temporary neutral position, it is what it says. It is for temporary use. So even if you are driving and you come to a traffic light, you may want to step on the clutch, disengage the gear, put the gear in neutral, and release the clutch while you wait for the light to change to green. So these are the two functions of the clutch. The two main functions progressively connect the transmission to the engine and provide a temporary neutral position. So the second thing, state the function or functions of the transmission. What is the transmission supposed to do for us on this vehicle? Okay, the first one, vary torque produced by the engine to suit load and speed requirements of the vehicle. Second one, provide a reverse gear. And third, provide an operational neutral position within the powertrain. So we take the first one first. Vary torque produced by the engine to suit load and speed requirements of the vehicle. So think about your car. You might have a situation where you are the sole person in your car. You get into your car and you drive from one location to another location. So the load in the vehicle is just you and the weight of the vehicle. But let's say, for instance, you happen to be a taxi driver. And now you have 5 passengers maybe in the car. So your car is loaded with people. Maybe these people also have packages with them that you will put into the car. So that adds even more load on the car. So when we talk about vary the torque produced by the engine to suit the load, we're talking about additional load that could be placed in the vehicle, or in the case of a commercial vehicle like a truck, load that could be placed in the tray of the truck or on the truck. The statement also talks about speed. So we know we don't just drive at one speed. Sometimes you are required to drive at slower speeds. Sometimes, depending on road conditions, you are able to drive at higher speeds. To achieve efficient functioning of your vehicle, it means you must select an appropriate gear depending on the speed at which you wish to drive at. Secondly, provide a reverse gear. Of course, it would be ridiculous if you had a car that could not reverse. All of us would understand the need for a reverse gear. So as such, sometimes or most times your car will drive in a forward direction. And of course, there will be times when you need to reverse your car or your truck. So to allow the vehicle to move in a reverse direction, the transmission is equipped with a reverse gear that allows the vehicle to go backward. And finally, provide an operational neutral position within the powertrain. So as was mentioned before, sometimes you want the vehicle to be working, but you don't want to be mashing the clutch for a long extended period of time. So it means you must be able to neutralize the transmission. And in this way, the engine could continue to work, but no drive will be transmitted to the transmission or through the transmission to the driving wheels. So in this way, the transmission provides an operational neutral position within the powertrain. Okay, so we're looking at some diagrams which indicates to us where transmissions and also the engine might be located. So traditionally, before the advent of front-wheel drive, engines were located at the front of vehicles. Behind the engine is located the transmission. Then we have a drive shaft. That will transfer the drive to the final drive, which is at the back of the vehicle. And of course, from the final drive, all the way to the wheels. So that is the traditional way that vehicles were built. The illustration below looks in greater detail at the engine, transmission, drive shaft, the final drive and differential assembly, and the axle shafts and the rear wheels, which will drive the vehicle. The illustration on the right is our front-wheel drive car. And now we see we don't have that final drive assembly. We don't have a drive shaft going to the back of the car. Everything is mounted to the front of the car. Engine, transmission, final drive, axles, and the drive to the wheels. So in this way, we see a radical change in the design of the drivetrain so that power from the engine to the wheels is routed differently. In this particular instance of front-wheel drive, the final drive assembly, meaning the crown wheel and pinion, which would be traditionally in the final drive, and your differential gears are now mounted within the transmission housing. So generally for front-wheel drive vehicles, we refer to that transmission final drive assembly as a transaxle. We also want to look at where the gear shift lever is located in the two illustrations at the top, the rear-wheel drive car and the front-wheel drive car. Both of them will have the gear lever located in a position where the driver has easy access to it and could easily reach it and shift the gears. However, in the rear-wheel drive car, the gear shift lever is mounted directly on the transmission. On the front-wheel drive car, the transmission is some distance away from the gear shift lever, so it will be connected to the gear shift by either cables or linkages. So we want to just remember that. So this is an up-close view of the inside of a transmission. And inside this transmission, we see some mechanisms. These are what we call gears, drive and driven gears. So sometimes we might wonder what inside the transmission is actually transferring that power from the engine to the output of the transmission. So in this close-up view, we are actually looking at the gears, or these mechanisms which we call gears, that actually transfer engine power to the output part of the transmission. So gears are commonly used, and of course there are different designs. Gears are commonly used for the purpose of transferring power. So there are different designs of gears. There are different designs of where they may be located, how they may be shaped, what is their particular function, how much load can they transfer. And remember, once they are working, friction is going to exist between moving parts, and we need to put some form of lubricant into those housings that hold these gears inside a gearbox, for instance, or a transmission. We need to put lubricant in there so that these gears could work with the minimal amount of friction and at the same time transfer the high loads that they are required to. So now we want to look a little closer at gears and what they do. So when we talk about gears, we quite often talk about gear ratios, because we know gear ratios allow gears to perform some of their important functions. So one of the things we had talked about previously is allow for varying engine output power based on vehicle speed and load. So gears are used to create what we call gear ratios. So in this first illustration, we're looking at a gear ratio that is 1:1. 1:1 means that the input gear has the same amount of teeth as the output gear. Also, the driving force of the input gear will be the same force that is transferred to the output gear. So there's no change in speed, and there's no change in the amount of force delivered when we have a 1:1 gear ratio. However, we could also have a situation where we have gears of different sizes or gears with a different number of teeth. So in this particular illustration, we see the input has 12 teeth and it is rotating at 1000 RPM. The output has 24 teeth, so it is larger, and rotating at 500 RPM because of that difference in number of teeth and size, or diameter, if you like. So this is an illustration of a reduction ratio. So the input here is a smaller gear with 12 teeth. The output gear, or the driven gear, is a larger gear with twice the amount of teeth, 24 teeth. So the ratio between these two gears is determined by the number of teeth in the driven gear divided by the number of teeth in the drive gear, and 24 divided by 12 is 2. So we have a gear ratio of 2:1, and that is referred to as a reduction ratio, as opposed to in the previous illustration where we had a 1:1 gear ratio. We have another scenario here now where we have a larger gear driving a smaller gear. So the input in this case has 21 teeth and is rotating at 1000 RPM. The output has 12 teeth and is rotating at 2000 RPM. And again, if we remember our formula for gear ratio, the number of teeth in the driven divided by the number of teeth in the drive would indicate that this particular gear ratio is what we will call an overdrive. So it means the input member is driving the output member at a higher speed, as we could see in the speed difference of 1,000 and 2,000 RPM. So the three type of ratios you will find in manual transmissions or any transmissions for that matter. In some instances, the transmission will be in direct drive. When the car is under load, a reduction ratio will be selected. And when you are traveling fast on the highway and the momentum of the vehicle is high, the gear ratio that will most commonly be used would be an overdrive ratio. And of course, these various gear ratios allow the car to convey different loads and achieve different speeds. And this is the function of the transmission. This is what the transmission must do for the car. We had talked about the vehicle being able to go in reverse. And generally, when we have a gear train of 2 gears, we need to introduce a third gear into that gear train to produce for us a reverse gear ratio. So we introduce what is called a reverse idle gear or an idler gear between the drive and the driven members. The idler gear does not change the ratio that exists between the drive and driven member. It simply forms a connection and causes the output to turn in the opposite direction. So in order to achieve a reverse gear in your vehicle, you need to introduce what we call an idle gear between the drive and driven member. And this is normally referred to as the reverse idle gear. So this is an illustration of how the gears would look inside a transmission. So they are arranged in a particular manner so that various gears could be selected to achieve the different ratios. So in this transmission, we see levers, and they connect to a mechanism at the top of the transmission. And those are the shift levers inside the transmission that would actually shift and a mechanism inside there called a synchro mesh. So it works on a hub that is part of the synchro mesh that will allow gears to be shifted from first to second, second to third, third to fourth, fourth to third, and of course, reverse. And if you have additional gears, because we do have manual transmissions that have fourth gears and fifth gears and sixth gears and so on. So depending on the type of transmission you have, you will have the appropriate amount of gears within the transmission housing that would allow you to select the appropriate gear for the load and speed of your machine. So remember in one of the first illustrations we looked at, where we saw that in the front wheel drive vehicles, the transmission was remotely located in the car in relation to the gear lever that is inside the car. So it means there must be some sort of connection from the lever that the driver is going to operate to the transmission itself. So anytime transmissions are located where the gear shift lever cannot be directly fitted in the transmission, it means the transmission must be connected to the inside of the car where the driver's gear shift linkages or lever is. There must be some sort of mechanism, either cables or mechanical linkages that allow the operator or driver to shift the gears. So this is an example of how the gears could be shifted when the transmission is removed from the gear lever itself. So this is an illustration of a transaxle. And the transaxle is a combination of the final drive, and your differential gears. And in this case, this transaxle, of course, is for a front-wheel drive vehicle. And we see axles coming out of the final drive. So it means the transmission gears will drive out of the transmission into the final drive. The final drive gear is connected to the differential assembly, which is itself connected to the two axle shafts. So here we see a transmission combined with the final drive, and the axles that drive the wheels are directly connected into the final drive assembly. So this is an illustration of how power is going to flow when we are in first gear. So we see the input shaft of the transmission. We see a gear that is the driving gear, driving into another gear that will be the driven gear, and there would be a ratio existing between these two gears because we see one of the gear is larger than the other. And because one of the gears are larger than the other, it means in this particular illustration, the input gear is larger than the output gear. So we have a reduction ratio. And as such, the vehicle is going to be, the engine's torque is going to be multiplied so that we have a higher torque generated because of that particular scenario. So the car now will behave as though it has greater power. However, even though greater power is being generated, the speed that the car will move with will be less. So it means you need, or the driver needs to select the appropriate gear for the conditions that the machine is operating under. So all the gears could be selected, first, second, third, fourth, and this is what that is exactly what we are seeing in this illustration. Now we are looking at power coming into the input, going through the fourth gear and being delivered to the final drive and to the axles. So for each gear range within the transmission, that same situation will occur with the operator selecting the appropriate gear to match the vehicle operating conditions, speed and load. This is the situation for reverse. And on the illustration on the left side, we see 3 gears now. And this is where the reverse idle gear has been inserted in connection between 2 other gears to provide reverse or a change in direction for the vehicle. So all of these gears are incorporated within the transmission. And in this particular transaxle, the drive is out of the transmission through an output gear to the final drive gear, from the final drive gear into the differential, which divides the drive into right and left axles. So this is a close-up of the inside of a transmission showing the mechanism that actually allows you to shift the gear from first to second. And later on, we'll see a component in there referred to as a synchronizer that is going to play a critical part in gear shift. So that brass looking or gold colored member we saw just now, this is a close-up of that. You would notice the gear referred to here as the output gear has a nice shiny part on it, and it looks cone-shaped. And that gold colored part, actually it is brass. that gold colored part is going to fit on that shiny part. And that gold colored part is pressed onto that shiny part of the gear to synchronize the gear. So think about driving your car. You are going down the road and you want to shift your gear. The car is traveling at a particular speed. The engine is driving the mechanism. You step on the clutch, you disengage, so you disconnect the engine from the drive, but the car is still moving. So it means you have components in the gearbox that is still rotating, and you want to select a gear. So it means the gear that you are going to select must turn at the same number of revolutions as the part of the gearbox that is connected to the wheels and still rotating. Now, in order to get that gear to turn at the same speed of the mechanisms in the gearbox connected to the wheels, this brass ring or this brass member is pressed onto that shiny part of the gear so that it comes to the same speed as the part it has to connect to. So this component is referred to as a synchronizer, and it allows for synchronizing of two components within the gearbox so that the gear could be engaged without clashing. Now, an important component of that synchronizing is the lubricant that is trapped on that member or on those two members that are trying to synchronize. So the most important function of the lubricant in a manual transmission or transaxle is to ensure that the ideal coefficient of friction exists at the synchronizers as gears are being engaged. Generally, a GL4 oil is most often specified or recommended. Now, that is a general recommendation. Synchronizer rings, commonly called brass rings, may be damaged by oil additives such as sulfur that is commonly found in GL5 gear oils. So it is important that you consult manufacturer's service manual or the vehicle's owner manual to determine the exact specification of the oil required by your transmission or transaxle, or you could consult with the oil producer or distributor for compatibility if in case you're not sure. So for instance, if you're not sure what oil to use in your transmission or transaxle, you could simply call NP, and they should be able to give you enough information that allow for you to select the correct oil. So on this note, I would like to end my presentation and thank you for your time and attention.
Thank you very much, Kiran Singh, Raghunanan Singh. I'm sure you agree that was very informative, very instructive. And this is now the opportunity we want to give you to ask any questions that you have. We were talking, of course, about manual transmissions. And every time we do these webinars, we give the instructor and the technical associate for Ultra the opportunity to answer any questions that you may have. And we have quite a few coming in, some on the chat and some direct message to us. So let's start. Kiran and Dwayne, are you ready?
Yes.
So the interest is high. Here's this one. This is so interesting when I saw this. Someone is asking, transmission fluids tend to have a very distinctive color. They make mention here of them being red. I don't know if there's a different color that we are familiar with. They are asking the question, is there a particular reason for this? Why is transmission fluid always of a particular color, distinctive color?
Yes, good day. So transmission fluids, the reason for the color, it's not to do with the performance, but really to identify it separately from, let's say, engine oils or coolants. So the color is an identifier for in case you have a transmission leak. This may be, so that's why most transmission fluids, may it be automatic transmission or CVT transmission, are dyed red in color.
Dwayne, very interesting as well. Here's this question that we have here. Are manual transmissions cheaper to repair and maintain than automatic transmissions?
Okay, so not necessarily. We do have transmissions now in the market that are high-tech units, and they will possibly cost the same amount or maybe even more than an equivalent automatic transmission to repair. So the traditional thought would have been that because of the way that manual transmissions are built, they would cost less. But the components inside of manual transmissions, as we saw, the gears and so on, those are extremely expensive to produce or to manufacture, let's say. And if you have to replace a number of those gears, the cost could be pretty high. Of course, for instance, there could be what we will call a catastrophic failure. Let's say, for instance, there was a leak on your manual transmission and you lost a substantial amount of fluid. It means those components would have been running without lubrication, which would result in damage to a substantial amount of components within the transmission. And it is going to be extremely costly to replace those components. So while in the past, it may have been cheaper to repair a manual transmission as compared to an automatic, currently, manual transmission costs about the same, or in some instances, even more than it would cost to repair an automatic transmission.
Based on what you just mentioned, I guess it's safe to say that repairs to a manual transmission is not one of those DIY or do-it-yourself projects. You know, there's some people who, they're very good with their hands and they will take on a DIY project and try to repair certain things themselves or change their oil for themselves. From what you just mentioned there, it's safe to say that manual transmission repair is not a DIY project, correct?
No, it is not. You need special tools, you need presses, pullers, special measuring tools in order to repair manual transmissions. And then we have to remember these transmissions are pretty heavy. So just the act of removing them from a car, it could be cumbersome and dangerous for persons who are not familiar with doing that type of work.
Very true. And safety ought to be a priority when you're dealing with these things, because from what you said, you have to hoist it up on a lift, given the
Yes.
weight, and so it would really not be something that you would recommend to do yourselves.
Certainly
Thank
not.
you. All right. So if that is the case, then what is the recommended preventative maintenance schedule for a transmission, for example, that has been rebuilt, let's just say?
So the most important component within a manual transmission, of course, is the lubricant. So you want to make sure that your transmission has no leaks. So you're not going to lose the lubricant over a period of time. Secondly, you want to know, or you want to ensure that you use the recommended lubricant in the transmission. So transmission oils have special characteristics. For instance, when you shift gears, you don't want excessive resistance, or you don't want to have to push too hard on the gear lever to cause the gear to shift. At the same time, you don't want to hear like gears grating while you're shifting the gear. So it means the correct lubricant in the transmission will allow the gear to shift easier with less effort from the driver and also with less noise, if we could use that term. So you don't want to hear any grinding or grating while the gears are being shifted. Lubrication of manual transmissions, like all mechanical components that have movement or rotating components within, they require lubrication. Because of the variety of manual transmissions and transaxles that we have, it is extremely important that you use the oil specified by the manufacturer, because under certain conditions, those mechanisms are going to be under extreme stress. And you want to make sure that the lubricant in there creates a film that separates the metal moving or rotating components.
Very much, Kiran. And, you know, once you start talking about the quality of lubricants and using them, Dwayne Bryan loves these opportunities to come in and give a plug for the Ultra name. So, of course, he would probably want to endorse what you're saying. Not so, Dwayne? You're muted.
Yes, yes, Denise. So as Kieran mentioned, using the correct specified lubricant is very important. That lubricants meet the wide variety of specifications of different manufacturers, such as Dana, different OEM manufacturers, right, such as MAN, ZF, Dana, and the API specifications, such as the API GL5, API MT1 for the different manual transmissions. And another point we wanted to make about it's the clean gear technology that the Ultra lubricants gear oils have in them. As I mentioned, most gear oils, and as Kieran mentioned as well, they tend to leave this yellow stain on the gear parts because they are manufactured with sulfur and phosphorus additives. Right? But the Ultra lubricants, we have this clean gear technology that does not leave that stain and provides with a longer oil drain interval, and as well to give you less failure and better protection in terms of your gear oil and your manual transmissions.
Dwayne, as we have you, stay there, please, because there are, you've answered a few questions that came in on the WhatsApp here about the benefit of using the Ultra gear oils. You spoke about the specifications that the Ultra gear oils meet, and I think you mentioned as well the intervals between the changing of it in terms of most vehicles, right? But here's a question though, why do gear oils smell so bad? Someone is asking.
So as I mentioned, the additive component of the gear oils, yes, they utilize a base oil and an additive package. So the additive component it's a sulfur phosphorus additive component. And the sulfur component of that additives has this type of rotten egg smell. So that's why you know that it's a gear oil as compared to an engine oil or any other oil. So the high sulfur content of the gear oils relates to the smell of the gear oils. Yeah.
A difference between an SAE 90 and an SAE 75W90?
Right. While both these oils meet the 90 body gear oil specification, the 75W90 is what we call a multi-grade gear oil. So it has this ability to flow faster at startup as compared to a straight body SAE 90. So most 75W90 gear oils are synthetic in nature, and it will be, of course, a better oil as compared to a straight body 90 oil. Yeah.
All right. Thank you so much. Kiran Singh, we're not done with you yet. You know, there are some questions here for you. Someone is asking in the chat, what parts are damaged inside a gearbox when you try to change the gear with engaging the clutch? So for example, when the engine is off and the vehicle is stationary, what parts are being potentially damaged inside the gearbox if you're doing that?
Okay, so we have the mechanisms within the gearbox that allow the gears to shift. And one of the critical parts that will become damaged is the components that make up the synchronizers. So the synchronizers connect two moving components within the gearbox. Let's say two gears, for instance. One of those gears will be driven by the engine, and one of those gears will be connected to the output of the transmission and to the wheels. So it means when you press the clutch down and you disengage the engine from the drivetrain, if the vehicle is in motion, it means one of those gears in the gearbox is still rotating and maybe at high speed. And you are trying to connect a gear, another gear that would have been driven by the engine. But before those two gears could be connected, both of them have to come to the same speed. So this is why this mechanism is called a synchronizer. Now, in order for the synchronizer to equalize the speed of these two rotating components, they are pushed together by what we call the synchronizer ring, the brass colored ring or the gold colored ring that we saw in the slide presentation. So it means if these two components are trying to engage without the speed being synchronized, any component that is trying to connect and traveling at different speeds or rotating at different speeds could become damaged. So we're talking about any component within the synchronizer assembly and the teeth on both of the gears that are trying to connect.
Thank you for that. Forgive me if the question that I'm asking is very similar to what you just said, but someone is also asking, when moving the stick and you hear that grinding sound, what is that sound about?
Right, so it means the synchronizer is not doing its work. It is probably worn out. So the two gears are trying to engage without the synchronizer having synchronized the speed between these two gears. So what you're actually hearing is the mechanism that is trying to connect the gear, physically trying to connect when two members are not turning at the same speed.
Right. I guess this other question is related in terms of transmission, delays in transmission responses. They're asking, why is the transmission delayed when going into gear? I hope I'm phrasing that correctly.
Well, it means that it is difficult to engage the gear. Now, oil plays an important part in the operation of manual transmissions. So Dwayne talked just now about the multi-grade gear oil, the 75W90, as compared to 90 body. So if, for instance, we have 90 body gear oil in a manual transmission, one of the things you may note is that early in the morning, when you now start to drive this vehicle, the gears might be a little bit difficult to shift. And the reason for that is that the oil in the gearbox is a little bit thicker. It is more viscous when it is cooled. After the vehicle has driven for a little bit and the vehicle warms up and the gearbox oil warms up, you find the gears start to shift normally without that added resistance. Now, this is the advantage of the multi-grade gear oil, the 75W90. The 75W90 at lower temperatures maintain the viscosity, or it doesn't get thick or more viscous as temperature drops. So it means if you have a multi-grade gear oil in your transmission, when you start up in the morning, the oil is not going to be too thick and too heavy to the point of causing difficult engagement of your gear. So if this is a problem that somebody is encountering, a simple solution is to change the oil from a straight 90 to a multi-grade like a 75W90, and that problem will be alleviated.
Here's a question for you, Dwayne. Someone is asking, what are the package sizes available for the ultra gear oils that were mentioned? And they also want to know if the ultra gear oils are compatible with international brands.
Right, so the package sizes, as you can see, we have them available in drums, pails, and in 1 liter quarts. Yes, they are compatible with international brands. Once the international brands meet these specifications similar to the ultra gear oils, such as the API GL5, API MT1, they are compatible with the international brands. They can be mixed with synthetic gear oils as well, because they are compatible with that as well. But we also recommend when utilizing a gear oil, as Kieran will know, it's to stick to the brand, because some of the additives may be different than different ones, than some different brands. So we recommend, like, if you're using ultra gear oil, use ultra gear oil. If you're using a different brand, switch out, flush, and then change. Yeah.
Thank you very much, Dwayne. Kiran, another question here has to do with the process that should be followed when starting a car that has a manual transmission. Is there a particular process that should be followed or a sequence that ought to be followed?
Right, so it depends on the type of vehicle. Some vehicles with manual transmissions, if you don't mash the clutch, the car will not be able to start. Meaning you will turn the key, but you will not get any response from the starter motor. It will not start the engine. So you must mash the clutch before the engine will start. So that is a safety feature that is built into certain vehicles. All vehicles don't have that. But it is important to remember, if for instance, the last time the car was parked, if you had left the car in a gear and did not press the clutch when you attempted to start the car on the next occasion, when you turn the key and the engine rotated, it will cause the car to move. And this could be dangerous. There could be somebody in front of the car or behind the car. There could be another vehicle ahead or behind of you. So it means when you are driving or starting a vehicle with a manual transmission, you ensure that the gear is in neutral, or if it is in a gear and you don't want to take it out of the gear, you have to mash down on the clutch before you start the car. So there is a safety issue related to this. But ideally, neutralize the transmission and then start the car, or in vehicles where you have the built-in inhibitor, it means you must mash the clutch before the vehicle will start.
Okay, thanks for the clarification. But what does double clutching mean though? Because you talked about the clutch a lot in that little bit there. What is double clutching?
Okay, double clutching is a process. Generally, it applies to trucks with a specific type of transmission. It is called a constant mesh transmission, and there are some components in the synchronizer assembly that was not included on those particular transmissions. So the driver had to use a particular technique to synchronize the speed of the input gear and the output gear. So generally, the driver will step on the clutch, disengage the gear that is currently engaged, tap the accelerator to speed up the engine a little bit, step back on the clutch, and then engage the gear. And most times that would allow the gear to engage without any sort of grating. So it's a technique that truck drivers will learn for the process of driving trucks that don't have synchronizer mechanisms built into the transmission. So this would have represented older trucks. Most trucks now will have synchronizers, so drivers are not required to double clutch. Now we do have other vehicles that have to use this process. So there are specialized manual transmissions, for instance, on race cars, where drivers will use this technique to change gears. And those transmissions don't use the synchronizers that I have been talking about previously. And there are special reasons for that. The gearboxes are built in a particular way, and the drivers who operate these transmissions, they become expert at double clutching and shifting the gears, basically synchronizing the input and output gears perfectly while changing or shifting gears. So double clutching is really a process of synchronizing input and output gear speeds when you're engaging the gear. How you do it, you know, there may be a couple different techniques, but generally the driver will step on the clutch, disengage a gear, mash the accelerator to speed up the input gear, then step back on the clutch, and then shift the lever to engage the gear. So it's the process of...
In some of what you said there, you mentioned trucks. And there's a question, as I hear the word truck, I think of bigger wheels, larger wheels. Someone is asking, do larger or heavier wheels cause more wear to a clutch as opposed to the size that would have been issued at the factory or by the manufacturer?
Okay, of course, when we have bigger wheels, we're also talking about greater loads. So a truck would be manufactured with components that will be able to handle those additional loads. The problem would arise when we have, let's say we have a vehicle with a specific size wheel, and then someone was to change that size and use a wheel of a larger size. So it means now you have interfered with the engineering of the machine or the vehicle. And in such a case, yes, the larger wheel could in fact put greater loads on the suspension components. It could impose greater loads on the drive axles. It could cause, because it would generate greater momentum. And of course, any component within the drivetrain, all the way from the engine to the wheel, could be under greater stress. Yes.
So we're going to just take two final questions before we wrap things up this afternoon. As you may or may not know, there was an alert from the Met Office. So there's a lot of flooding in rising river levels. I want to believe that many of our mechanics who would normally tune in and ask a ton of questions, they may be caught up in that. So I want to take this opportunity to remind everyone that we are streaming live on the YouTube channel. And even if you don't get to see or participate in this moment live, you can certainly go back to the YouTube channel and view the webinar there. So the last two questions that we're taking this afternoon, one has to do with the lever. Shastri is asking, he says there are times when attempting to shift the gear lever to the reverse position in a manual transmission, you might encounter some problems. It's a little problematic. He's saying it's as if the lever is sticking. Is there any explanation for this?
Okay, so first of all, we have been talking about synchronizers. Quite often, the reverse gear is not one of those gears that would have a synchronizing unit. So quite often, you must stop the car before you try to engage the reverse gear. And generally, the force with which you engage the reverse gear should be a little bit measured, because you might hear a little bit of grating when you try to engage the gear, because there's no synchronizers on reverse. So most transmissions are built in that way. The reverse gear is not synchronized, meaning you don't have these synchronizing mechanisms. So the driver has to be a little bit cautious and careful in selecting the reverse gear. So for instance, when driving forward, the car is in motion when you're selecting gears. So synchronizers are required. Generally, when you're selecting reverse, the car should really be stopped. So if the car is in motion when you try to select the reverse gear, you will encounter what we call grating of the gears. So really, a car should be at standstill to select reverse. When you're driving forward, you could shift all the forward gears while the car is in motion, because you have these synchronizers associated with the gear train. Now, there could also be other malfunctions in the transmission that could cause the reverse gear to be difficult to select. Of course, it depends on the type of vehicle. We have seen some vehicles, the gear shift lever is directly on the transmission. There are other mechanisms where we have cables running from the gear shift lever inside the car to the transmission. Sometimes those cables need adjusting. So if those cables need adjusting, maybe you could get difficulty in not only the reverse gear, but any one of the gears shifting properly. You could also have situations where you have bushings and so on associated with the gear shift lever. And if these bushings are worn out, you might have difficulty in selecting gears, including the reverse gear. Yes.
Very nice. Thank you very much for that, Kiran. We'll just take the last question now. Is it okay to leave a vehicle in gear to assist with the parking brake? For instance, when parked on an incline. Kiran?
Yes. So again, we have to see what the manufacturers say about this, because all vehicles are not the same. And we could use an example. There are some diesel engines that once those engines rotate, they start. So if you leave a a truck, let's say, with a diesel engine, with one of that type of diesel engine, you leave the vehicle in a gear. If the vehicle starts to roll, the engine is going, the wheels at the back of the wheels that drive the truck will drive the final drive, turn the drive shaft, drive the gearbox components, and drive the engine, meaning turn the engine, and the engine could start up. And if the truck is in a gear, the truck will start to drive on its own without anybody in the truck. In such a situation, or in trucks that are equipped with engines that operate like that, the manufacturer is going to recommend that the truck never be left with a gear engaged. Most newer trucks, however, are equipped with electrical bypass systems that would prevent a diesel engine from starting if you leave it in a gear. And in many instances, when trucks are parked, drivers will leave those trucks in a gear because a diesel engine has high compression and it could actually assist in holding a vehicle in a fixed position. So for some vehicles, it is okay to place the transmission in a gear while the vehicle is parked. In other instances, the manufacturer is going to say, no, the vehicle must be left in neutral with the parking brake engaged. And if you need additional security to secure the vehicle, place blocks at the wheels of the vehicle. So again, it depends on manufacturer's recommendations and the situation in which the vehicle is being used.
Thank you very much, Kiran Singh Raghunanan Singh, NESE instructor for over 20 years. We certainly enjoyed that question and answer segment with him. And of course, we also need to thank Mr. Dwayne Bryan, Ultra Lubricants Technical Associate, who also capably answered all of our questions as well. So to all of you who are viewing on Zoom and those of us looking on live on YouTube, we thank you for your attention, for your very interesting questions. Let me tell you about some of the upcoming sessions though, before we invite NESE to talk about some of their programs. So far we've had 3 webinars, and the next webinar is scheduled for Wednesday, the 15th of September. It's entitled Keeping It Cool, and that's deliberate because we'll be discussing cooling systems, the operations, and the maintenance of them. So join us again on the 15th, Wednesday, the 15th of September, 2021, as we discuss cooling systems, operating, and maintaining. So at this point, just before we give away some prizes, again, we did promise that we would be giving out prizes at every webinar session. We would like to invite Mr. Kevin Manik-Chan from the NESE's School of Continuing Education to talk about not only some of the programs that they have upcoming, but a lot of what you learned today about the manual transmissions. They have programs that are designed to teach you a whole lot more. Kevin, would you share with our viewers some information on the programs, please?
Thank you very much, Denise, for that warm words of introduction. And I'd like to start off by thanking the team, the NP team, the School of Continuing Education team, for this collaboration and bringing such knowledge to actually raise the industry standard practices as it relates in the automotive industry. This will augur well moving forward in terms of we bring mechanics to international standard in when we get these modern vehicles. With that being said, the NESE has benchmarked all our programs to international standard, where we offer diploma programs, where we can be able to train not only mechanics, but persons in heavy equipment, persons in welding, persons in plumbing, persons in electrical, in being qualified to get the jobs there in the industry. Presently, NESE is recruiting at our 4 major campuses to commence classes on the 20th of September. And we've set a deadline date of the 27th of August to get all our registrations in. All persons are invited to visit our website, www.nesc.edu.tt, where they can apply to our programs and they'll walk through the process and someone will contact them to move forward as it relates to our courses. Now, at the School of Continuing Education, we also offer short courses that are available part-time, and it varies in length. Those are really geared towards professionals who are working but need some sort of qualifications. And we offer programs through our website. We also, based on these collaborations with NP, when we formulate a demand for programs, we can be able to, on the spot, be able to offer programs for a group of persons who ideally want to get a training solution for a group of persons, be it in a company or persons coming together. This year, we have dubbed our training moving forward as Jumpstart Your Career. Jumpstart your career, be it a career change, be it upskilling, in terms of you want to be multi-skilled, because we live in a global landscape where we want portability to be able to work anywhere in the world. So with that being said, we look forward to answering any questions anybody would have. You can put it in the chat. You can keep on with us, visit our website, right? Right now, we have a flyer that is being showed with our diploma courses that is being presently recruited for, right? And just to let persons know that the program is GATE approved for 2 years, where we go through to get GATE funding. And we have 4 major campuses. We are in Point Lisas, St. Madeleine, right? Chaguanas, Woodford Lodge, and of course, Sister Isle, Tobago, right? And those are a list of all the courses we are presently recruiting for. And one thing I can say about our program, when it relates to the energy and the energy-related field, there's always a job market for NESC's diploma program. And we are proud to say that our persons are capably placed in industry where there is a demand for labor. So I'd like to thank each and everyone for attending this webinar. Thank NP again for this opportunity. And I turn you back to our host, Denise. Thank you very much.
Thank you very much, Kevin Manik-Chan, Senior Business Development Officer at NESC. So just to recap, we talked about shifting gears, manual transmissions today, but if you're tuning in, and we certainly hope you are, to the next 3 sessions in the webinar series, you can look forward to these topics. On Wednesday, the 15th of September, as mentioned, we'll be looking at cooling systems, where we discuss keeping it cool, cooling system operation and maintenance. On Wednesday, the 20th of October, the theme is hit the brakes, and that's deliberate because we're discussing brakes, hydraulic systems, the operation and maintenance. And then on Wednesday, the 17th of November, there's so much talk, and that's because we'll be looking at drive shafts and CVT joints. Again, this webinar series is designed specifically for mechanics, but we know that we have our spare part outlets who are tuning in. We know that we have our NESC automotive students who are tuning in as well. And then we have regular car enthusiasts who are just interested in learning more about how the vehicle functions and how to get it functioning properly. So we certainly welcome you, and we look forward to you joining us in the future. As mentioned, we know that today, because of widespread flooding across Trinidad and Tobago, our participation levels would not have been as high as we normally expect. But nevertheless, the link is on YouTube. We're streaming live, and you can always go right back there to take in the full episode or the full webinar when you have the time. On to our next item, which is one of those much anticipated features in the webinars, and that is our prize draw. As we always say, we give out prizes at every webinar session, but the people who are rewarded are the ones who would have attended the previous session. So I want to share with you the names of the 10 winners of our webinar 2 that was held last month. I'm going to call out the names of the 10 winners, and on screen now you will be seeing an image of the products that they will take home as prizes. Again, it's the Ultra Lubricants brand, but when we reach out to you, because what will normally happen is that after I call the names of the winners, you will get an email right after the webinar session tonight that will explain to you the process that you have to follow in order to redeem your prize. So let's call the names of our winners. And we want to say congratulations to all of them in advance. So taking home a 1-gallon bottle of our Ultra Lubricants product, which will be specific to the vehicle that you drive, are Alex Singh, Andrew Punyat, Avanel Rupnarain, Claude McKenna, Darian Ford, Jaden Rodney, Joshua Fraser, Kareem Hernandez, Kazim Tula, and Kerwin Wellington. Again, congratulations to all 10 winners. You don't have to worry about what happens next, because you will receive an email right after tonight's webinar telling you exactly what you need to do to collect those prizes. So we're certainly happy for you. I know it must be coming at a much needed time. So we thank you very much for being diligent in not only registering on our page, but also tuning in every week to the episodes and the webinars. So we invite all of you who are viewing now to do the same thing. You can get a chance to win any number of prizes by just tuning in to our programs regularly. So ladies and gentlemen, our viewing publics, we've come to the end of today's webinar session, and I need to close by thanking some of the key people who you see both in front of the camera and behind the camera. So we want to say thank you, a heartfelt thanks to Kiran Singh, Raghunanan Singh from the NESE, Dwayne Bryant, Melissa Thomas, our NP team who work both in front of and behind the camera, to Yinka Charles David, who is always so diligent in pulling off these webinars for us, working behind the scenes, to Sulin, to Stephen, our sales reps for the Ultra brand, always diligent, providing that support. And anyone who I have not named, I want to just say thank you. Kevin, of course, Manik Chan, you are included in the thanks. That's the NESE's involvement. And to all the other NESE instructors as well, we want to say a heartfelt thank you. So this is it, the end of webinar 3. And we certainly look forward to welcoming you to the other webinars upcoming. Thank you so much for joining us. We do encourage you to keep safe, and we look forward to seeing you on another occasion. Ultra Lubricants, protecting what counts. Have a good evening.
Bye.